Hey guys, so before we get started with these problems, I want to make sure that we are clear about the definitions, right? And I know that there is a links to an answer key. There are just some things that I want to go over with you. So what's really important for this unit is this handy equation box up here in your notes, okay? So the first thing that you guys should have realized is that when we talk about delta E and delta H, you should realize from our discussions about thermochemistry that they are interchangeable. Okay, so don't think that they are separate items. Okay, they are all interchangeable. Now, what's really important are these definitions, and I'm just going to point them out to you just so when we go through these energy diagrams, it'll make more sense to you. Okay, so here we go. For the delta E forward, when we talk about that, that is going to be the products minus the reactants. When we talk about delta E reverse, that is going to be the reactants minus the products. Okay, that one's pretty easy. If we're going in the forward direction, that means that we are going to be subtracting the energy from the products and the reactants. The reverse is going to be the other way around. Okay, that is what is going to let us know what's going to be positive and negative, depending on the level of energy that each of those things have. The other thing on the other side that I want you guys to pay attention to is this idea of EA, which is going to be considered the activated complex minus the reactants. Basically, what this is it's going to be activation energy. So for a reaction to happen, okay, the products of the reactants have to get to, let's just say, a higher level where there is some sort of energy above and beyond the products and reactant that is required for the reaction to happen. For AE prime, that is going to be the activated complex minus the products. Now, the reason why I'm doing that is because if you have to label them on a graph, it'd probably be a good idea to know what the definitions are. Okay. So let's do number one together. And I'm going to try and make my pen smaller because I'm going to be drawing on this graph. All right, so it says on the energy diagram below, label the reactants, products, activated complex, and then you have to determine all of the values. So it wants you to determine delta E forward, delta E reverse, EA, and EA prime. All right, so the first thing we have to do is identify where everything is. Okay, so this is the forward reaction. This is the reverse reaction. If you remember, it says that you're going to put all your reactants at 0. Okay, so right across here, I'm going to draw a dotted line to let you guys know where 0 is going to be. So down here is where my reactants are. Okay, hopefully that makes sense. Now we take a look at, looks like it's about the 50 line. Let's see if I can draw a straight line here. It's a little bit of a struggle, but I think I got it. All right. Right here, this is going to be the 50 line. This is going to be considered the products. Okay. The last thing you need to label is the highest point in your graph. So let's put another dotted line up here. This is going to be considered, I'm just going to put AC. This is the activated complex. Right? I'm just following what I know to be true about reactions. I have my reactants that start at a certain level, and then I'm going to go up to my activated complex, which is going to transform my reactants into products, for likely of a better term. All right, so now we need to label everything. So if you take a look at your definitions, right, you know that delta E is always going to be the difference between the products and the reactants. So I am going to, just to make this easier, I'm going to write products up here so you guys don't get confused. Okay. When we're talking about delta E is going to be the difference between the products and the reactants. Okay, and I'm going to make sure I label that appropriately as delta E. The next thing, it wants me to label EA prime. Well, EA prime, if you take a look at your definition, is going to be the activated complex to the products. So that is activated complex to the product line. Okay, let me make my line a little bit smaller. This is going to be AE prime. And then it wants me to label my EA. So EA is going to be the activated complex to the reactants. So let's label it activated complex to the reactants. Okay, this is going to be regular old EA. Okay, so that is the first part of the equation. I've labeled those three things. Now it wants you to determine the value of delta E forward. It also wants you to determine the value of delta E reverse. And then it wants you to find the value for EA and the value for EA prime. All right, so to do this, we just need to know what the numbers are. So for E forward, it is going to be the products minus the reactants. Your product line is at 50 and your unit is kilojoules per mole. Make sure you take a look on the axis of your graph. And we are going to subtract that from the reactants. My reactants are at 0 kilojoules per mole. So the answer to this is going to be 50 kilojoules per mole. Okay, that's the first answer. The second one is asking us for E reverse. E reverse, if you take a look at your definition, is going to be the reactants minus the products. My reactants are at 0 kilojoules per mole. My products are going to be at 50 kilojoules per mole. So that answer is going to be minus 50 kilojoules per mole. Next thing, it's asking me for EA. So EA, if you take a look at your definition, is going to be activated complex to the reactants. Your activated complex is sitting up here at 80. So it is going to be our activated complex, which is 80 kilojoules, minus our reactants, which are here at 0 kilojoules per mole. So that means that this is going to be 80 kilojoules per mole. Now it's asking us for EA prime. So EA prime is once again that activated complex, which is 80 kilojoules per mole. And since it's prime, it's going to be minus the products. My products are right here chilling at 50. So that is going to be minus 50 kilojoules per mole. So this answer is going to be 30 kilojoules per mole. Right? Hopefully that was helpful and you guys will be able to get through the front side of the worksheet. I will do some problems on the back side just so you can see what's going on over there. Okay?